Dear friends, engineers, architects, and my MEP students, uh, this particular module we are going to discuss uh, about basic electricity. This is basic electrical engineering. I will try to teach you within half an hour or so. Friends, electricity is generated by converting primary energy source such as coal, natural gas, nuclear fission, wind, or sunlight into electrical energy, usually by rotating a generator. Most methods use steam or direct mechanical force like wind or water to spin magnets inside coils of copper wire, creating an electromagnetic field that induces electrical current. Utilization of electricity involves four main steps: generation, stepping up, that is increasing voltage through transformer; transmission, moving high voltage power on transmission towers carrying conductors. Conductor may be copper or aluminum. And distribution, lowering voltage through transformer for home or office use. Most electricity is produced by spinning a turbine with steam, water or wind, which turns a generator to create an electric current. Friends, slightly on basic concepts, an element of an atom. All matter is composed of molecules which are made up of combination of atoms. Atoms have a nucleus with electron, this is nucleus, and electron with electron orbiting around it. The nucleus is composed of protons, this one plus charges. These are protons, and these are the electrons orbiting around this. Electrons have a negative charge. Protons have a positive charge. Neutrons are neutral. The negative charge of an electron is balanced by positive charge of the protons. Electrons are bound in their orbit by attraction of protons. These are referred to as bound electrons. Free electrons. Electrons in the outer band can become free of their orbit by application of some external source such as movement through a magnetic field, friction, or chemical action. These are referred to as free electrons. A free electron leaves a void which can be filled by an electron force out of the orbit from another atom. As free electrons move from one atom to next, an electron flow is produced. This is this this flow of electron is the basis of electricity. Friends, electricity is generated in two different forms: DC, direct current voltage, AC, alternating current. In DC, uh, in this time versus voltage graph, DC is uh, constant, voltage is constant. In case of AC, the voltage fluctuates in a sinusoidal waveform. This is sinusoidal waveform. So this is a time versus voltage curve of AC. This is time versus voltage curve of DC. In both the cases, you can see if you are applying DC voltage through a battery, the current flow is something like this, clockwise. This is the load and this is the current flow. In case of AC, you are applying AC through some generating set. The current flows to and fro. One cycle like this, another cycle like this. Friends, now something on alternating current. Alternating current AC is the type of electricity supplied by national grid and used in most homes and workplaces. In an AC system, the flow of electricity does not just move in one direction, it repeatedly reverses direction at a fixed rate. In the UK, this happening is 50 times per second, and not only in UK, in all those countries where UK has ruled one time, that is India also. 50 times per second, which is called a frequency, and 50 Hz. In other countries, it is 60 Hz. Other country means America and even the way what actually alternating is the polarity of the voltage and the direction of the current. AC sine wave, alternative voltage and current vary continuously. The graphic representation for an AC is a sine wave. This is the sine wave. Here is the time and here is the current or voltage. So, this thing is full cycle from here to here, but this is known as half cycle positive and half cycle negative direction. And the time taken is in entire cycle from here to here 20 millisecond. AC is used for power distribution because it is efficient to generate, easy to transform to higher or lower voltages, or transmission and supply, and works well with a wide variety of electrical equipment. Three-phase systems require TP, triple pole, TP plus neutral, triple pole and neutral, or four-pole, residual current devices to cover all live wires and of course neutral if present. Friends, the fundamental law behind electrical flow is Ohm's law. You must have learned in your school time in physics and now in electrical engineering. The basic Ohm's law states that the electrical current through a conductor between 2 points is directly proportional to voltage across the 2 points. Introducing the constant of proportionately the resistance represented by R. One arrives at the three mathematical equations used to describe the relationship. It is V equal to I into R, voltage equal to current into load resistance, R Current is equal to voltage upon resistance. R R equal to V upon voltage upon current, where I is the current through the conductor, V is the voltage measured across the conductor, and R is the resistance of the conductor. More specifically, Ohm's law states that R in this relation is constant, independent, and the current. Actually, R varies with the temperature. In case of AC current, R is replaced by Z. In resistance, we say Z, which is impedance. That is impedance taking the effect of capacitance and inductance of AC circuit. In Cartesian form, an independent impedance is defined as Z equal to R plus J into X, where the real part of impedance is the resistance R and the imaginary part is the reactance. And this reactance is made up of capacitance, inductance, or combination of both. Friends, just to revise basic electrical quantities, electric current is the flow of electric charge, electrons, and its unit is ampere, mostly represented by I. Voltage written as volts. It is electrical pressure that pushes current. Its unit is voltage, volt. Third is resistance. Opposition resistance or impedance opposes the current flow, and its unit is ohms, either in DC or in AC. And just to revise, I am to discuss basic component of electrical transmission and distribution system. Any electrical system fundamentally needs a power source, that is generator here, alternator or AC generator or DC battery. Conductors, these conductors throughout. Wires or cables or simple conductors or bus ducts to carry the current. Third element is transformers. One transformer here, and there may be several transformers. Control devices. Those are switches, breakers, or isolator for transmission and distribution management. Now these control devices are circuit breaker and circuit breaker. They may be in the form of switches or isolator also. And finally, a load at the end, a load that may be lighting, bulb, motor, any other electrical apparatus to use the energy. Friends, just watch this diagram and I will tell you how the electricity is used ultimately. This one, there could be a man receiving a station feeding so many substations in case of large campus, and this voltage may be 33 kV. Normally it is 33 kV or above. This is called man receiving station. You take electricity in big campus through man receiving station, through electricity board, normally called utility. Now this man receiving station is connected to several substations in the campus, 1, 2, 3 and many more. I will describe only one substation. You have received electricity through ST panel, and before this ST panel you are metered for payment purpose. ST panel converts is connected to transformers, a number of transformers, in this case only two, and this transformer convert 11 kV here to 433 directly, and this is feeding LT panel, so-called medium voltage panel. This medium voltage panel, from one panel we get several main switch boards, MSBs, and these MSBs are feeding to TPN DV or SPN DV. TPN means triple pole and neutral DV in case of three-phase AC supply about 450 volts, or it can be SPN DV also, single pole and neutral, working at 240 volts. After this TPN DV, we get number of circuits. The four-way TPN DV will give you 4 into 3, 12 circuits. Each circuit consisting of 1 kilowatt. So from four-way TPN DV you get 4 kilowatt load fed. If it is 6, you will be getting ultimately 6 into 3, 18 circuits. If it is 8, you will be getting 24. And if it is 12, you are getting 36 circuits. 36 circuit means 36 kilowatt. And each circuit I have shown here is made up of roughly 1 kilowatt, or as perceptibly 800 volts, 800 watts, and that may be divided between 5 ampere circuit outlet. You may have several points. It may be in the form of lamp, some other points, some other point. I have shown this one is called non-substitution, and these may be bus ducting type of thing. These conductors. Here the conductor may be cable or bus duct. Here also it is normally cable. And from this cable these are the main circuits. Man. And from man we are getting divided into sub-main circuits which are feeding TP. So this is sub-main circuit. From sub-main circuit we come to circuit, and from circuit we come to points. So hierarchy is like this: electrical point, then electrical circuit, then electrical distribution board, the sub-main distribution board, then main distribution board. These main distribution boards are fed through medium voltage panel, and these are getting electric supply through 11 kV or 33 kV, this one, and we get each substation gets supply from main receiving station, which may be 33, 66 or 132, and in a campus there may be substation. The modern distribution system, we provide one substation for one individual building. Okay, this is enough. Friends, enough as far as electrical engineering concerned. Uh, for interior designer, this much knowledge about electricity is sufficient. The electric generation from electric turbine, it uses steam or it uses flowing water or wind, and these from steel, combustion gases, flowing water or wind, we come to a rotor of a generator, which is coupled with the stator. This rotor is outside this one, and this stator is inside this, and then we get the electricity which through the transmission tower and enhanced voltage. Normally this voltage is 13.6, 11 to 13.6, and through transformer it is enhanced, and through transmission tower it is taken to various residential unit or office units. So okay, thank you for constantly and meaningfully watching my presentation. Thank you again from Engineer VK Jain.